Assalamualaikum, Dr. Haryati. My name is Nurul Fadzlin. So today I would like to present my infographic based on my selected journal, which is entitled The Continuous Microfluidic Purification of DNA Using Magnetophoresis. So the term magnetophoresis has been proposed to describe the behavior of a magnetic particle moving through a viscous medium under the influence of an external magnetic field. Its origin can be traced to a similar term used to describe the particle motion in a viscous medium under the influence of an electric field, which is electrophoresis. So this automatic microfluidic purification of nucleic acid is predictable to reduce the input of original samples and improve the throughput of library preparation for sequencing. Before the modern technologies could be used, the nucleic acid separation had been a time and work-consuming process based on the several extraction and centrifugation steps, often limited by small yields and low purities of the separation products, and not suited for automation and upscaling. During the last few years, specifically functionalized magnetic particles were developed. So this is the overview of the magnetic separation procedure. Firstly, the magnetic particles, which is in gray color, are appropriately functionalized with an affinity ligand, which is in a blue color. While the green one is the peptide, and the incubated alongside the sample containing the target analyte, which is in a red color. Then the magnetic bits bound to the target are collected by application of an external magnet before the bits are washed to remove any non-specifically bound material. Finally, the target protein is eluted from the magnetic particles using the suitable elution buffers. For this study, the researchers demonstrate the novel microfluidic system using an external neodymium magnet to isolate the DNA from the PCR mixture. The DNA was purified and isolated when the DNA carrier bits transported to the interface of multilaminar flow under the influence of magnetic field. Prior to the DNA recovery experiments, the simulation software was used to study the relationship between the trajectory of bits and magnet positions as well as fluid velocities. Afterwards, the experiments to study the influence of varying velocities and input of samples on the DNA recovery were conducted. So these are the advantages of using this method. So these biomagnetic bits could be both highly specific and highly sensitive at a relatively low cost with respect to the separation equipment. Not only that, this purification also such an efficient tool that the nucleic acid can be directly isolated after their extraction from the crude samples. Thus, the protein complexes that tend to be broken up by the traditional column chromatography techniques may remain intact when using the very gentle magnetic separation procedure. So these are the basic materials and equipment for laboratory experiments. Firstly, we need the magnetic carriers with immobilized affinity or hydrophobic ligands. Second, the magnetic particles, which prepared from a biopolymer that has exhibiting affinity for the target compounds, or magnetic ion exchanges that is usually used to perform the isolation procedure. And last but not least, the magnetic separators of different types that can be used for magnetic separations. And these are the work mechanism. Generally, the extraction of DNA from PCR mixture Live cells of bacteria requires 3 steps, which are binding, washing, and elution step as illustrated in the figure A. So this method, however, leads to the time consuming for the experimental operation. Then the figure B shows the approach designed to execute these 3 steps into a branch chip. The chip consists of one main channel connected to the 3 branch channels at both left and right side. The solution of DNA carrier bits, washing buffer, and the TE buffer are continuously injected into the 3 inlets respectively. Then the DNA carrier bits pass across the interfaces of different buffers via magnetic force provided by external permanent magnet. As a result, in figure A, it shows the recovery efficiency of DNA with different input amounts. In this section, the microfluidic chip implements continuous purification of DNA in small amount. The recovery efficiency of DNA decreases with the increase of input samples from 100 nanogram to 500 nanogram at the flow rate of 120 microliter per hour. So it shows that the elution time for the increased DNA carrying bits declines when the input of samples increases. While in the figure B, it displays that the velocity of fluid has a slight impact on the DNA recovery efficiency. The maximum of recovery efficiency is 98.4% with the input of 100 nanogram at the flow rate of 40 microliter per hour. Then lastly, the DNA purity is evaluated by the UV spectrophoresis and electrophoresis. To conclude, this method is hopefully to be improved as one of the advanced tools in the DNA purification and increase the throughput of library preparation. Growth in the magnetophoresis research and its application is aided by many synergy between material science, experimental and computational fluid dynamics research, and etc. Then this leads to emerging applications such as detection of paramagnetic impurities in diamagnetic samples and biomagnetic cell separation. These are the areas of magnetophoresis applications that will likely continue to rapidly grow, and it should provide a fundament for further automated sample preparation. So that's all from me. Thank you.